let's get this party started. So let us say we have a block that is on an inclined plane. So let's read the problem. A 6 kilogram block is on an inclined plane that forms an angle 45 degrees with the x-axis. If the block is stationary, calculate the force of friction. Well, we should, the first thing we want to do is start off by labeling our forces. So we should hopefully all by now realize that there's one force that pulls all of our objects down, and that's going to be a force of gravity. And there should also be another force that all surfaces produce, and that is in fact going to be our normal force. Okay, but what other forces do we have? Well, one thing we really need to be aware of by now is this. Oh, let me label my normal force, sorry. Is that this particular force of gravity can actually be split into two components. Let's do them both in red. Sorry, they don't all converge in one point. So what we end up having, guys, is this. You have a force of gravity parallel to the surface and a force of gravity perpendicular to the surface. And the important thing to realize is when you do this, guys, when you break the force of gravity into its pieces, well, just like if you broke a pencil into its pieces, the original form of the pencil doesn't exist anymore. So actually for this problem, it doesn't really matter. Now, the last thing it says is this is at equilibrium. And it's at equilibrium because of force of friction. So what you see is this. You see that you also have another force pulling up the ramp. Now, this force right here that pulls up the ramp that prevents us from sliding down is our force of friction. Okay, so we've got four forces. Now, the one thing to realize is this, is that the formula FG parallel is going to come from FG sine theta, and our FG perpendicular equals FG cos theta. Now, the big thing to recall as well, guys, when using these formulas is that FG equals mg. Now, in this case, FG equals, we have a 6 kilogram block, 6 kg times negative 9.8, sorry, everything's not going to fit in here, 1 meters per second squared. The units will be off the paper. Okay, so when you plug this in, guys, I'm just going to simplify it. I'm going to say that Fg equals, I don't have my calculator with me right now, some value. You'll get the value. You can do it in your calculator. And that value then gets plugged in here. And then you're going to take your theta of 45 degrees. So you're going to get your value times 45 degrees, and you should be able to get your parallel and perpendicular. Now, once you've done your calculations, and you need to be able to do your calculations, so then you need to realize this. For equilibrium, equilibrium tells us that F net equals 0. 0 newtons, whatever. And F net is always equals ma, or also the sum of our forces. And in this case, we have F parallel, or FG parallel, sorry. FG, or that was perpendicular. FG parallel plus force of friction plus Fn. Now, something you should do, look at the picture, and hopefully you realize, guys, that this block is going to slide down the ramp. Therefore, it's only going to move in something that we could call basically parallel, this parallel direction. So it's not going to move in the perpendicular direction, and that means we're at equilibrium for sure in the perpendicular. So these two forces, this guy and this guy, if you take a look at the parallel and normal force here, here's our parallel, or I'm sorry, perpendicular and our normal force here. This is our perpendicular, and this is our normal force. They're equal but opposite, and they'll cancel out. Now, you should also realize, with equilibrium, these two are going to be equal but opposite, but we don't know our force of friction, and we can find that. Force of friction, when we rewrite this, Now I want you to substitute 0 here, and then just ignore this for right now. So you get 0 newtons equals Fg parallel plus F of F. And what you'll end up getting, your final answer, and you'll have to do calculations for it again, is that Fg parallel negative Fg parallel equals F of F. And that negative just tells me they're going in opposite directions. Okay, you guys do the math.